We continue with the discussion of solution of fully developed fluid flow. And fluid flow, as we define, is the fluid that takes place between two infinite plates, with one plate fixed and the other plate moving with a certain velocity, that is v. So when we consider that, there were certain assumptions which we have listed, and with those conditions, because that is for a steady motion, so no variation with respect to time, and therefore, and also it is incompressible, no changes with respect to density, and therefore the continuity equation, as you know, will be reduced to only del V is equal to 0. If you recall the continuity, the other components or parameters appearing in the complete equation will disappear. So it is reduced to this, and in component form, it is equal to partial derivative of u with respect to x, partial derivative of v with respect to y, plus partial derivative of w with respect to z, where u, v, w are components of the velocity vector v in x, y, and z direction respectively. Based on the assumptions that are mentioned here, this is just for a reminder why we are saying that because of the assumption, these factor will not contribute anything. They will give us 0. So they don't have any contribution because they are 0. The only velocity that is acting is along the x-axis. So only there is the velocity u that will be contributing to continuity equation. And therefore, this equation, the continuity equation, as I write down here in the vector form, reduces to delta u by delta x equal to 0. So, for solution of continuity equation, we need to solve it. And if I have to integrate it, it will be u is equal to something. What is that something? We come to that in a minute. And this is only telling us that this is not a function of u, because when we differentiate u with respect to x, we obtain 0. This is equal to 0. So that means as far as u is concerned, you can depend on y, you can depend on z, but it does not depend on x. So this is the inference that we take from here. And in other words, it doesn't matter where we place the origin. So the origin can be here or here. Wherever we see, the velocity will be the same if we make a measurement of the fluid flow at some point. Then as far as x-axis is concerned, the value of the fluid particle that is moving is changing with respect to y, but not with respect to x. So even if I take the values of velocity at this point, that will also have the same values as they are here, or as they are here, or as they will be somewhere here. So that is the implication of this, and this follows from assumption 1, and the equation 1 is also telling this. And then it is also given that the two plates are infinite, and remember the distance, the gap between the two, in geometrically it may look large enough, but it's not very large, but a certain small gap of course is there, and a certain distance greater than 0 does exist. Now therefore, from it follows that since u is not a function of time also, or therefore or either z, so the only other possibility is that u will be a function of only y. So possibly when we integrate the continuity equation, you remember we obtain from there delta u by delta x equal to 0. When I integrate this, I will have u is equal to some constant u of y, something like that. So that's what we will have done, and that comes out from the continuity equation.